Hi guys, this is your quiz review for tomorrow's quiz on linear equations. We did this in class, but I'm going to go through each problem again. Jennifer bags groceries at Wegmans. On average, she fills 5 bags for every 3 customers. Alright, so on the graph represent the total bags Jennifer filled based on the number of customers. So because it's based on number of customers, that means this is going to be my input or my x. So down here, I'm going to label my x-axis as customers. I'm going to go ahead and just label it by ones. All right, and then my y-axis is going to be how many bags, okay, because that is based on it. So my y-axis is going to be the bags. Looks like she's doing 5 bags for every 3 customers, so I'm going to count by 5s. Okay, I'm going to graph it. So 5 bags for 3 customers. So I'm going to put my first point right here. 5 more bags for 3 more customers. Here comes my next one. 5 more bags, 3 more customers, and then that's all I can fit on this graph. All right, I'm going to connect my points. Here's our line for Jennifer. All right, it is asking me, what does the average rate of change represent? Okay, well, the rate of change is the bagging versus the customer. So it is showing bags per customer. Remember, this keyword right here, per, is always part of what the average rate of change is doing. All right, what is her rate of change? Well, it told us right here, 5 bags for every 3 customers. So her rate of change will be 5 over 3. Okay, remember that means 5 bags per 3 customers. All right, write an equation that represents the situation. Okay, so remember we're going to use y equals mx plus b, where m is our slope and b is our y-intercept. We just figured out the slope right here, didn't we? It's 5/3. So we're going to have y equals 5/3 x. And then b is our y-intercept. Well, if we look at my graph over here, my y-intercept is 0. So you can put plus 0, but you don't have to. You could leave it just like this. That is the equation of the line. All right. Next one, we have Zach and his friend Cody both mow lawns. Zach earns $375 per week mowing 15 lawns, while Cody earns $500 per week mowing 25 lawns. Construct a graph that represents Zach's earnings per lawn and Cody's earnings per lawn. We're going to do 2 lines on the same graph. Okay, so right here, this $375 per week, $500 per week, that's giving me my X and my Y. Okay, so what's my input? That's the weeks. What's the output? The money they're getting. Okay, so my weeks are actually my X's and my money is my Y's. I'm going to label my X-axis as weeks. Our Y-axis is going to be money. All right. Count by ones when it comes to my weeks. When we do the money, I'm going to count by 125. And then 500, 750. Okay, I think that's enough. All right, so we need to do Zach and Cody. So I'm going to do Zach's first. Well, Zach is $350 per week. So that means 1 week, $350 right here. To keep it going, I'm going to go up $375 more. Okay, so from the beginning, I went up 1, 2, 3 blocks and over 1. I'm going to do that again. 1, 2, 3 blocks and over 1. Do it again. 1, 2, 3 blocks over 1. And then doesn't fit anymore. Nice, coming from our origin. Here we go. This was Zach. All right, let's do it again for Cody. Cody is making $500 per week, okay? So when my week is 1, he made 500 right here. So this one went up 1, 2, 3, 4 over 1. I'm going to do it again. 1, 2, 3, 4 over 1. So $1,000 in 2 weeks. And then it goes off the chart, so I can't really do the other one. Let's connect these. There we go. There's Cody. Okay. What does the average rate of change for each graph represent? Okay, so my rate of change, remember it told me up here, it is money per week. Okay, it is the money they made, so money made per week. All right, who has the greater rate of change? Well, looking at these two graphs, we see Cody's graph is steeper, which means his rate of change is higher. We can also see it in the description. Zach was only $375, Cody is $500. This lawn right here information, this is extra information that we actually don't need. Okay, it's not part of our problem. So we're looking at just their rates. Okay, Cody has a greater average. What does that mean? It means he makes more money each week. Okay, we can also see that his graph is steeper. All right, let's write an equation for this one. Let's do both. So let's do one for Zach and one for Cody. So Zach equals, remember my slope, which it gave me right here, he's $375 per week, and then my y-intercept is 0, so I don't have to do anything else for Zach. Cody is $500 per week, so he's $500W. And remember, you can put the plus 0 if you want to. It's not necessary, though, so it can look either way. You could have just kept this $500W. All right, so there's Zach and Cody. I'm going to come down here to the tub. Jennifer Lawrence has an ancient bathtub that drains slowly. She filled up her tub and then let the water drain out to see how long it would take to drain. The graph below represents the number of gallons of water remaining in the tub and the time in minutes. Use the graph to answer the following questions. All right, part A. How many gallons of water are in Jennifer Lawrence's tub after 6 minutes? All right, well, my minutes are down here. So with 6 minutes, that's going to give me this point, which is matching up with 12 gallons. So after 6 minutes, we have 12 gallons of water left in the tub. All right, what is the slope of the lines? Remember, that's rise over run. So let's pick 2 points. I'll start at the beginning, and I'm going to pick this point right here. Okay, so to get from point A to point B, we're going down and then to the right. So because we're going down, we know we're going to have a negative number. We went down 2 blocks, right? But each block is 2. We went 20 to 18 and then 18 to 16. So from 20 down to 16 is actually going down 4. So we're going to show that as -4. And then we went over 1, 2, 3. That is per minute. So we went over 3 minutes. All right, what do the numbers of the slope represent? Well, because we have -4, we lost 4 gallons of water. That's showing me that we are draining, or we're losing, 4 gallons of water every 3 minutes. All right. Part D, what is the x-intercept? All right, so that's this guy right here. That is where x is 15 and where y is 0. What does that mean? All right, well, remember my x's were my minutes and my y's were my gallons. So this is showing me it's going to take 15 minutes to have 0 gallons. Okay, so it's telling me that it's going to take 15 minutes for the tub to be empty. For no more water. All right, what about our y-intercept? Okay, well, that's up here. So it looks like I have a y of 20 and an x of 0. What does this mean? Well, again, this is minutes, this is gallons. So 0 minutes, 20 gallons. So that means that the tub started, this is your key word for your y-intercept, started with 20 gallons of water. Okay. So again, slope was negative, which makes sense because our graph was falling down. We were losing the water. Okay. These graphs were going up, which makes sense because they were earning more money each week. Okay. Let's go to the back. We are graphing a ton of lines back here. We can use y equals mx plus b, which will work every time. So every time this is going to work out for you. Or we can use the intercepts to graph. Okay, remember that means that my x and my y, they're on the same side. What we can do is we can make just my x piece equal to my value and then just my y piece equal to my value, and we can get the x and y intercepts. Okay, this works. I mean, it does work every time, but you don't get whole numbers every time. So I would be careful with your intercepts. Okay. Right here, 4x plus y equals 0. I'm going to put it in y equals mx plus b. To do that, I'm going to subtract 4x from both sides. I end up with y equals negative 4x plus 0. So that means my y-intercept is 0. Our slope is negative 4. Remember, whole numbers means that they're over 1. So we're going to go down 4 and to the right 1. To go backwards, I'm going to go up 4 and left 1, like that. All right, connect my dots. There we go. Here's our line. All right, number 5. We have 10x minus 3y equals 15. So again, you could cover up the x and the y. But right here, look, you have to do 15 divided by 10. That's not a whole number, okay? So I don't want to mess with that. Let's just get our y by itself. So subtract 10x from both sides. This will give me negative 3y equals negative 10x plus 15. Then we're going to divide each piece by negative 3. So the equation on my line will be y equals positive 10 over 3x, and then minus 5. Negative 5 is my y-intercept. We're going to go up 10, which is all the way up here to positive 5, and then over 3. And we can't go backwards to this one. It's not going to fit. So, there we go. All right, number 6. So we have x and y on the same side. This one, we can't use our intercepts. Look at that. If I cover up y, we have x equals negative 3. And then if I cover up x, I have y equals negative 3. So I can very easily plot those 2 points. Here is where x is negative 3. Here is where y is negative 3. And then I can go ahead and connect them. So when the intercepts work out, it's very nice. But we just got to remember it doesn't always happen. All right. Number 5, x equals 5. Okay, well, here's x equals 5. You might notice there's no y in this equation, which means this line will never touch the y. For that to happen, it has to be a perfect vertical line, straight up and down. Every single point on this line has an x of 5, but never is going to actually touch the y-axis. All right, number 8. 7x plus 2y equals negative 10. Again, I can try to do intercepts, but look right here. We're going to get negative 10 divided by 7, and that's not going to work out for me. So let's get y by itself. Subtract 7x to get 2y equals negative 7x minus 10. Then we're going to divide each piece by 2. So this will simplify to y equals negative 7 over 2x and then minus 5. Y-intercept is negative 5. Again, I can't go down 7 and over 2, can I? So instead, I'm going to have to go up 7 and to the left 2. Right there. Okay. All right, number 9. Let's see if my intercepts work here. All right, x equals negative 6. I like that. And cut up the x. Negative 2y equals negative 6. I can divide 2 into 6. So here we go. X equals negative 6. We like that one. And then negative 2y equals negative 6. Well, if I divide both pieces by negative 2, y equals a positive 3. So we're going to use these intercepts. So y of positive 3 is here. X of negative 6 is all the way on the edge. And then here we go. Right? Halfway there with the graphs. Number 10. Okay, we have 9x plus y equals 4. Okay, so if I do my intercepts right here, that's not going to give me a whole number. 4 divided by 9, not going to work. So we're going to get y by itself. To do that, we're going to subtract 9x over. So we have y equals negative 9x plus 4. Start where y is 4. Go down 9 and to the right 1, because every whole number is over 1. Okay. We know my line's going to fall down because the 9 was negative, and because it's such a big number, we know it's going to be really steep. So it's going to fall real fast. All right. See how this one, well, I'm not going to use that one. All right. 11, y equals 5. All right, well, let's plot that point. Y, 5, right here. Again, notice there's no x's in this equation, so this line will never touch the x-axis. So to make that happen, this line has to go perfectly horizontal, so it never crosses. There we go, y equals 5. All right, number 12. Let's see here. Ooh, x equals negative 12. That looks good. And then I can divide 12 by 4. So we have x equals negative 12. And then we have 4y equals negative 12. Divide, we get y equals negative 3. Now, that worked out beautifully. But is this not helping me? Well, y equals negative 3 is not the problem. But x equals negative 12, that's not even on my graph. So, even though it worked out nicely, I'm going to need to know what my slope is so I can graph the rest of this line. All right, so over here, we're going to subtract the x. So we have 4y equals negative x minus 12. And we're going to divide each piece by 4. So the line is y equals negative 1/4 x and then minus 3. So we knew that was going to show up because that is my y-intercept. But now I know my slope. Our slope is negative 1/4. So we're going to go down 1 and right 4. And then to go backwards, we're going to go up 1 and to the left 4, like that. And then connect these. So see how this number was smaller? My slope was 1/4, so it's not going to drop down as fast. Versus this one, when it was 9, it's a larger number. That's why it was so steep. All right, 3 more, guys. There we go. 13. We have 7x plus y equals 5. Intercepts this time aren't going to work because 5 divided by 7, not a whole number, not going to do it. So let's get y by itself. All we got to do is subtract 7x to the other side. So we're going to get y is equal to negative 7x plus 5. Start where y is 5. This means drop down 7 and go over 1. Connect those. There we go. Again, it was a larger number, right? So we're dropping down faster. All right, 14 right here. Oh, intercepts are not going to work. Negative 5 over 3 is not a whole number, so I don't want to mess with it. Let's just get 5 by itself, right? Subtract 3x first. So we have 5y equals negative 3x minus 5. Then divide each of these pieces by the 5. So now we're going to have y is equal, well, it doesn't simplify, so it's going to stay negative 3/5 x and then minus 1, like that. Y negative 1 is here. Negative 3 means fall down, and then move over to the right 5. I can go backwards by going up 3 and to the left 5. All right. Last one. Let's get y by itself. We're going to subtract 6x from both sides. So we have 5y equals negative 6x plus 20. Divide each of these pieces by 5. We're left with y equals negative 6 over 5x and then plus 4. Here's where y is 4, negative again, drop down 6, go to the right 5. I can't go backwards because it's going to go off the graph, so I can only put those 2 dots on there, which is fine, and then connect them. There we go. All right. If y'all have any questions, try to come see me in the morning before first period. Your quiz is tomorrow. Happy studying and good luck.